Okay, we did real well getting here. As soon as I pointed out that this thing has zero force on it between the walls because it has constant speed and direction when it's between the walls. Okay? But there's got to be a force because the velocity is changing. The velocity being the speed and direction. So once we get the idea that the velocity changes, you got an initial velocity as you're going into the wall, a final velocity as you come away from the wall. We don't know anything about the time interval here because we don't know the dimensions of this thing, and if it's a particle, it has zero dimensions. But what we can say is the initial momentum is mvi, the final momentum is mvf, right? Where these are now the vector velocities. The magnitudes of both velocities are v, but they have opposite directions. vf is negative vi, so that the change in momentum has a magnitude of 2mv. Put all this together, you see that. It's going this way with velocity v, now it's going this way with velocity v. If this was plus 10 meters per second, then it would be doing minus 10 meters per second when it comes away from the wall. That would be a change of final minus initial, negative 10 minus 10, which is negative 20 meters per second, for example, right? Okay? And then the delta t, and everybody did well with this except we said collisions with one of the walls. And everybody wanted to tell me that the time interval between the collisions was L over V, which is not bad until you consider that it has to go 2L to get back to the same wall. So we have delta T is 2L over V, right? So the magnitude of the average force is what? Well, that's the magnitude of the change in momentum divided by the magnitude of delta T, which is 2mv divided by 2L over V, which is mv squared over L. And now, what do you see about any of this expression? Well, mv squared looks a whole lot like kinetic energy, right?
Yeah.
But it isn't kinetic energy. What is it? It's double the kinetic energy because kinetic energy is 1/2 of that, right? So this is twice the kinetic energy divided by L. And that's kind of a big deal to start right off with.